Welcome to another lecture event in our walk down the road of decision science. Today we look at the topic of forecasting. Now, in virtually every decision that we make, whether it is in business or in our private lives, we must consider some kind of forecast, where a forecast is simply a prediction about the future. Sound predictions of demands and trends in the business world and within our personal life cannot be regarded as a luxury, but a necessity if we are to cope with the seasonality of life, the sudden changes in the demand for the product in businesses, the price-cutting maneuvers of the business competition, strikes, and large swings of the economy. Forecasting can help us deal with these troubles, but it can help us more the more we know about the general principles of forecasting and what it can and cannot do for us currently, and maybe which techniques are suited to our needs at the moment. So here we're going to try to scan the basic principles of forecasting. When you read your text, you will see them talking about categories and types and kinds. Here we will just stick with the simple thought that there are three kinds, well, two categories. Let me start by saying that we usually talk about two categories of forecasts. So the categories we normally talk about are the qualitative category, Q-U-A-L-I-T-A-T-I, qualitative category, and the Q-U-N-T-I-T-A, and the quantitative category. Now we arrive at this thought about qualitative and quantitative category with the understanding that there are different types of forecasts. So we talk about the types of forecasts being like an economic forecast, where we seek to predict what the economic situation will be like, bare economy, high inflation, etc. We also talk about another type of forecast, which is a technological forecast, T-E-C-H-N-O-L-O. Technological forecast, which seeks to try to figure out what is the rate of change of technological invention, because technological invention drives a lot of the innovation that we have in the processes that we use in our economy. So that is of particular interest also. And then now, the third one, which gives rise to our discussion about qualitative and quantitative forecasts, is demand forecast, where the business seeks to predict the demand for the products, the goods and services that it is within the market to offer. So our talk about categories of forecast is taken place within the context of demand forecast. So within the discussion of demand forecast, we usually say that there are two categories: the qualitative category and the quantitative category. The quantitative category is further divided into what we call the time series methodology and the causal methodologies. Good. So two categories, qualitative and quantitative. Under the quantitative, you have a further division into time series and the causal methodology. So let's have a look at what we mean when we talk about the qualitative category. Now, qualitative techniques primarily are used when data are scarce. For example, when a product is first introduced in the market, they use human judgment and rating schemes to turn qualitative information into quantitative estimates. So here, you use judgments, rating schemes to turn qualitative information into quantitative estimates. The objective here is to bring together in a logical, unbiased, and systematic way all the information and judgments which relates to the factors being estimated. You find that such techniques are frequently used in new technological areas where development of a product idea may require special inventions, so that research and development demands are difficult to estimate, and where market acceptance and penetration rates are highly uncertain. So you find that these qualitative methodologies, usually we have what you call the Delphi method. And in the Delphi method, what we have is a panel of experts is questioned by a sequence of questionnaires in which the response to one questionnaire are used to produce the next questionnaire. Any set of information available to some experts and not to others is thus passed on to the others, enabling all the experts to have access to all the information for forecasting. And what this does is that it eliminates the bandwagon effect of majority opinion, or what you call it in when you're doing decision making, and everybody pile on to somebody and that person changes or her mind. There's another name, you can look for it. And then you have what you call the market research. Here, what you have is a systematic, formal, and conscious procedure for evolving and testing hypotheses about real markets. And you can have what we call panel consensus. Good. Here, this technique is based on the assumption that several experts arrive or can arrive at a better forecast than one person. There's no secrecy and communication is encouraged, and the forecasts are sometimes influenced by social factors and may not reflect a true consensus. So you realize that in these qualitative methodologies, you're relying heavily on the opinion of experts, right? And notice I'd set the background that it is used when you have a scarcity of historical data, right? Usually in situations where products are new, demand for the product is new, right? So we go on to look at the quantitative methodologies. One of the best known quantitative methodologies, time series, right? And these statistical techniques, the time series analysis is statistical techniques that are used when several years of data for a product or product line are available. And relationships and trends are usually clear and relatively stable. So the basic principle here under the time series is that historical data are available and the forecaster can use and should use the data on past performance to get a kind of reading on current sales, for example. Now, It's not really just as simple as it sounds, but it's an explanation of what it is to accomplish. Now, time series, therefore, is a set of chronologically ordered points of raw data, meaning you have data, raw data, that is collected over some time period, right? So for example, a division sales of a given product is collected by months or by years, right? So, or by days. Now, what the time series helps to do is to identify and explain any regularity or systematic variation in the time series data. So it explains systematic variations in the data due to seasonal factors. It also identifies what we call cyclical patterns that repeat any 2 or 3 years or more. It also establishes what we call trends in the data. And it also can tell you about the growth rates of these trends. So the assumption then behind time series is that the existing patterns that were discovered in the past will continue in the future. Now, this is an assumption, right? So it assumes that the seasonal, the cyclical, the trends, the growth rate that you would have uncovered in the historical data, that they will continue in the future. And this assumption tends to be generally more correct in the short term than in the long term. So you find that these techniques, these time series techniques, can provide us with reasonably accurate forecasts for the immediate future, but they're not to be generally used for the long term, as they tend to do poorly when used for long-term forecasts. So time series analysis is usually for short-term to medium-term forecast. Now, let's talk about the causal model, not casual, causal. Now, when the historical data that we have gathered under the time series category are available, and we have done enough analysis on that data to spell out explicitly the relationships between the factors to be forecast. So under causal, we're looking at relationships between the factors to be forecasted. Or between, let me rephrase that, between the factors to be forecasted and other factors such as related businesses, economic forces, socioeconomic factors. You know, the forecaster often construct a causal model, right? And you find that for the causal model, it's pretty sophisticated, and it usually expresses mathematically the relevant causal, meaning cause and effect, relationships, right? And it tends to include every piece of known information that you can quantify that impacts or will have some bearing on the variable that you want to forecast in some kind of mathematical way, right? Now remember, time series, now let me add something to time series. It's really time series and trend. So the quantitative elements is really time series and trend. And under the causal, you usually have what we call the regression model. Now, students often ask, so Miss, what's the difference between the regression and the trend? Well, the short answer is that while the regression, which is the main tool for the causal modeling, regression looks at relationships that impact the variable that you're trying to predict. Under the trend, you are graphing the collection of a set of historical data against time, always against time. When you're doing regression, you do not include any time element. In the trend forecasting, you're always regressing against time. And so you find that what makes the distinction between a trend line and a regression line is the nature of the relationship or the absence of a relationship as against simply looking at the movement of a variable over time. So if you're looking at the movement of a variable over time, we call that a trend equation. If you're looking at the relationship between and among variables of interest, we say that we are looking at a regression equation. What often tends to puzzle students is that what the equation, the mathematical construct look the same. Yes, that is so that the mathematical construct may look the same. Why the mathematical construct may look the same? It is because of the presence of some kind of linear element in both analysis. The linear element uses a particular methodology, and that methodology is called the least square methodology. And the least square methodology is common to both the derivative of a trend equation or a trend line and a regression equation. The least square methodology is where you use is only for sum of xy minus sum of bxy. So again, the distinction between a trend line and regression line lies in what you are looking at. For a trend, you are looking at the movement of data over time, some element of time. For a regression line, you're looking at relationship that exists between the variables that you're seeking to predict and what influences are operating on that variable that you're trying to predict. All right, so keep that thought in mind. Now, so we go forward with looking by doing. So we're gonna look at some time series methodology and how we can effect some prediction about the future, that is some forecast, by applying some time series methodology. Now I'm gonna put a series of data points on the board, and then we're gonna work together on them. So get out your calculator. So it's going to be an interactive session going forward. Yes, it's a lecture, but it's a tutorial type kind of lecture. So I'm going to put on the board a series of time data. So our first example, a company's monthly sales. So I'm going to be writing for a 7-month period were as follows. You have the little table. So I'm going to draw a little table. So I'm going to be quiet for a little while. So you have the month. Remember, a time series is a set of data points that are gathered over some kind of time frame, whether that time frame is a month, a day, a year, a quarter, but some time element is there. So here our time element is month, and the months run from January to July. And then you have our sales in thousands of units. So 7 data points should be good enough to work with. Not too long, enough to give us an idea of what it is we are learning here. So the sales for January, so it's 20, remember it's in thousand, so that means 20,000, 19, 16, 21, 18, 23, 19. And I'm going to write the instructions now. So we're going to forecast sales according to the instruction that we're going to write. So I'm going to write the instructions to the side. So you're going to make sure you have the data in front of you. So when we flip the page, we can go along together. All right, so the instructions is 1, forecast sales for August, not August, sorry. Forecast sales for August using a 3-month moving average. Now, a moving average is just what it says. It's an average that consists of always using 3 data points, and as new data becomes available, you roll forward with the newest data and drop the oldest data, but you will always be using 3 data points. So you have 3 data points, you average the data points. Whenever new data points become available, you drop the oldest one, you pick up the new one, but you will always be using 3. That's the general principle of a moving average, or a 3-point moving average, or n-point moving average generally. N mean however many data points you're instructed to use, then you use that number of data points, and you always have that number of data points. When you're rolling through time, you ensure you have the specified number of data points, where n is any given number to you, and you continue that until you exhaust the information based on the instruction. Now, notice my emphasis, based on the instruction. So the first is forecast sales for August using a 3-month moving average. Now I want you to pay close attention to the instruction. Then the next one says forecast a 3 months forecast sales using a 3-month MA, means moving average. Now you're going to say, but Miss, instruction 1 and instruction 2 is the same thing. Not quite. So pay attention to the instruction, right? Then the third instruction is forecast sales So the next instruction is forecast sales using a 3-month weighted moving average. We will have a discussion on each as we begin the process. So we're going to begin the process of trying to make a prediction for the future based on the instruction that we're given and using the time series methodologies. Now, the time series methodologies usually consist of a series of averaging processes in some shape or form, plus the trend line method. Now, in the averaging method, you can be instructed to find any number of data points average. So you may be asked to do a 3-month moving average, a 4-month, a 5-month, or even a 1-month moving average. A 1-month moving average has a specific name. It's called naive forecasting, N-A-I-V-E. So if you're doing a 1 month, a 1 day, a 1 year, meaning you're just using one data point, then usually we call that a naive forecast. You're simply using what happened in the last time period to make a prediction for the current time period. And that goes by the name of a naive forecast, right? And you can think what naive means and why we may call it naive, right? No. So n may be any given number from 1 to however many number of data points. Here, we're using a 3 months because 3 is a reasonable number to use, easy to maneuver, so you don't have a lot of information to work with at this point, but the principle remains the same, all right? So the first instruction says we're gonna forecast sales for August using a 3-month moving average. In this instruction, we're asked to make a forecast for a specific time. So what it means is that we put our finger on the time that we want to forecast for. In this case, it is August. So in this case, it is August, but August is not in the data that we're given. It means that we're forecasting for some time in the future immediately after the end of the information that we're given. So August comes immediately after July. Why is it that we can do that? It is because we're using data in the immediate past in the specified number of points right before the month we are interested in forecasting for. So August did not appear in the original table, but we were asked to make a forecast for August. It means we put our finger on August and we go back to 3 data points immediately in the past from August. So immediately in the past from August, we would have July, June, and May. So therefore, a 3-month moving average for August would be we count immediately 3 months past. In the past from August would be July plus June plus May. And since it is 3 months, we would be dividing by 3. So you take your calculator and you add those data points, which according to the calculator, so you're doing it with me to get the practice. According to the calculator, you would take 19 plus 23 plus 18. You sum that, you will get 60, and you divide by 3, you will get 20. So Our response is for August, we forecast that the company will sell 20,000 units of the item. Why 20,000? Look at the heading, it says sales is in thousands of units, but for ease of operation, we drop off the thousand. You basically divide through by 1,000. So for August, we predict that the company will sell 20,000 units of the product. Now, that was for a specific month. Look at the instruction from question 2. It says forecast sales using a 3-month moving average. It did not specify any particular month. When your instruction looks like that, what it is asking you to do is to roll through the data from the beginning to the end of only the data that is in the original table. So then what you do is, I'm going to replicate the table next page so that we can have a clear view. So we have January, February, March, April, May, June, July. This is the information we were given. Again, it's 20, and remember it's 20,000, 19, 16, 21, 18, 23, and 19. So remember, we're looking at the instruction 2, that says forecast sales using a 3-month moving average. Unlike instruction 1, there is no specific month requested in question 2. So then how do I tackle that? Again, for repetition, when the instruction looks like question 2, when there's no specific month or time given, it means that you are required to go from the top, the beginning of the table, down to the last entry in the table, and only the information given in the original table you're being asked to make a prediction for. So how do we do that? All right, well, let's see how we do that. Now, remember it says that you are to use a 3-month moving average. Sorry. So what it means is that beginning at the very beginning, you count off the number of data points you are requested to use. So if it was 2, you would count off 1, 2, and you begin at the 3rd line. If it were 4, you count off 1, 2, 3, 4, and begin writing at the 5th line. If it were a 6-month moving average, you would count off 1, 2, 3, 4, 5, 6, and begin at the 7th line. In this case, you are asked to do a 3-month moving average, meaning you count off 1, 2, 3 months. That is 3 months of data are assumed to have been recorded, and therefore you will begin at the 4th month. Notice that there is no gap. So I didn't count 1, 2, 3 and then go begin at the 5th month. I counted off 1, 2, 3 and begin at the 4th month. So in this instance, your first average would be at month 4 because you have counted off 1, 2, 3, and you're beginning at the 4th month. So for the first average would be 16 plus 19 plus 20. So you take your calculator, and again, you tap in your numbers. Remember, it's averages. So it's 16 plus 19 plus 20. equals 55. You divide 55 by 3, you get 18.33. And where you're not instructed about the number of decimal places, 2 is an expected number or an accepted number. So then that's your first forecast. Now remember I said when no time is specified, it means you must roll right through all the given data from top to bottom from in the table given. So it means then having done the first one, we now are at May. So at May, you go 3 months backwards now. So since you're at May, you're gonna go 3 months backward, which is April, March, and February. So you're gonna pick up 21 plus 16 plus 19. So notice that you have rolled forward by picking up a new number of 21, but dropping the old number of 20. And you continue. So you do your averaging now, which is, you clear your calculator, and it's now 21 plus 16 plus 19 equals 56, and you divide that by 3, you get 18.67. Remember the rules of rounding, right? 18.67. And then you come to June. So at June, you would go 3 months into the past, which is 18 plus 21 plus 16. So notice I'm not picking up anything from the line at which I'm writing. So 18 plus 21 plus 16. Again, I've dropped the 2 oldest and I've picked up the most current. So notice now you do your 18 plus 21 plus 16. Again, that's equal to 55. You divide by 3, always be dividing by 3, and it's 18.33. And then you come to the last one, which is July. So for July, you would pick up the 3 immediate past from July, which is 23 plus 18 plus 21. So here it's 23 plus 18 plus 21 divided by 3. So again, notice at April, I picked up the 3 immediate past, 16, 19, 20. Notice I did not pick up the information from April because the assumption is that 3 months are now done and the information for April is not yet in. So I am working at April, assuming that the April figure is not in as yet, right? And that's the thought process, why we do not pick up from the line within which we're writing. So for July, so we would not get July figure until July is ended and August has started, right? Good. So for example, so for July, it's 23 plus 18 plus 21 equals 62, and you divide by 3, and that's 20.66. So look at the difference in your responses. So look carefully again. Let's go back to the instruction. The first one said, forecast sales for August using a 3-month average. Here is that response. The second one says forecast sales using a 3-month moving average. It did not specify any particular time. Here is your response. That requires you to run through the entire data set that is in the original table given in the problem only. That's what that means. Good. So this is how you would tackle such a question that asks you to make a forecast without giving you a specific time. If you're given a specific time, such as in question 1, then you put your finger at the time that you're asked to make the forecast for, and you look for the number of data points immediately in the past from the point you're asked to make the forecast for. All right, forecasting is a smoothing process, meaning that you smooth out the highs and the lows and make the data appear similar, right? So you take the variations as much as possible out of it. So if I want to give an idea of how the class record of your achievement in grades look like, if I want one number to say how the class is doing, I simply add everybody's grade and divide it by the number of persons in the class. So I have one number to say, on average, this is how the class is doing. So the person who might have scored 100 would have compensate for the person who might have gotten 40, right? So your grade is smoothed out. No, what do we call them? Highs or low or outliers are there. We squish everybody together. Now that implies that every grade or every number has equal value. So when you do a simple average, so a simple 3-month moving average or endpoint moving average assumes that every number is of equal value. It is not always true that every data point is of equal value. Some data points carry more weight than other. We want it to show that it carry more weight than other. For example, in your grading scheme, an A carries more weight in your grade point average, your GPA, than say a C. We want it to show that you have done very well. So you find that more points are given to you when you get an A than when you get a C. So the A will carry more influence. It will bump up your GPA, right? So you have your GPA being calculated by the University of Technology using the weighted average method. Now here in part 3, you're asked to make a prediction about future sales by using the weighted moving average, meaning the person who is instructed you recognizes that the past, near past, or far past may be influencing the sales, the future sales in a particular way, and the weights will reflect that. Now, how the weights are given to you, you must read very carefully. Here it says forecast sales using a 3-month weighted moving average. But notice that I did not tell you the weights. So it means that I have not completed the instruction as yet. So we're going to go forward with question 3, and I'm going to add what the weights should be. So at this stage, whenever you're asked to do a weighted moving average, you must always be given the weights and be told how to apply the weights. So I'm going to turn the page and I'm going to rewrite question number 3, and I'm going to write a complete instruction of what it is it should look like. Excuse me a minute, please. All right, so we're back. So I'm going to turn the page and I'm going to pick up with part 3, which is forecast sales using a 3-month weighted moving average. And I'm going to add the remainder of the questions that you should have, right? So I'm going to use a new page to go to question 3. Right, so we're doing part 3, where it says forecast sales. Now notice I just said sales. I did not give you a specific time. So it means you have to go through the entire data points, right? Forecast sales using a weighted, sorry, that should be a 3-month weighted moving average using the following weights. .5 for the most recent, 0.4 for the next most recent, and 0.1 for the third most recent. So the complete instruction then for question 3 looks like this. Forecast sales using a 3-month weighted, moving average using the following weights. So now I'm completing the instruction by telling you what the weights are, and then I'm going to add how you should apply the weights. And how is as follows. 0.5 for the most recent, 0.4 for the next most recent, and 0.1 for the third most recent. So the question you should immediately ask is, what do I mean by recent? How do I determine what is recent? Now, since you're always going back into the past, it means you must determine your starting point. So you determine the starting point. Where am I standing at to determine where the past should go? So it says use a 3-month weighted moving average. Here again, you're not told a specific month to make the forecast for. So it means that like the question before, like this question, you're going to have to go through the entire data point by first counting off the number of data points that you need to determine where you should begin your working from. Now, when you have determined where you should begin the working from, then you can seek to determine where the past lies. So in this instance, we're going to go look at the data. For ease, I'm going to replicate the same table. That is the table with the blue information on the page with the instruction. So we don't have to be going back and forth, right? So this question 3, I'm going to replicate the data on the next page so we can have it to look at right away. So we go to the next page. Again, the same data we will replicate January to July, so you can head up your page. January, February, March, April, May, June, July. We're going to use the same data, 2019, and remember they're in thousands, 16, 21, 18, 23, 19. Now it says that the weights that we should use are 0.5, right? I didn't know. 0.5 for the most recent, 0.04 for the next most recent, and 0.1 for the third most recent. Good. So again, as I said, recent depends on where you begin your working from. So since it's a 3-month weighted moving average, again, we count off 1, 2, 3. So it means that our starting point is at the 4th month because we must count off 3 solid data points in the past. So if we are beginning at month 4, because we're counted off 1, 2, 3 months in the past, then here is where we begin. Here is where we begin. That's us standing in the present. So it means that the most recent past would be March. So it means that 0.5 would be for March. The next most recent past would be February. So it means the 0.4 would be applied to the information in February. And the third most recent past would be in January. So 0.1 applies there. So it means then that when we're calculating our first weighted moving average, we would start at April because we have counted off 1, 2, 3 months in the past. So it means our starting point would be April. And then now looking back in the past from April, the most recent month in the past from April would be March. And so you count recent, most recent, next most recent backwards like that. So your average would be 16 times 0.5 plus 19 times 0.4 plus 20 times 0.1. Now, when you're doing a weighted moving average, you are going to divide by the sum of the weights. So the sum of the weights is 0.5 plus 0.1 plus 0.4, and that is equal to 1. So when you're dividing into the numerator, and it's a weighted moving average, you no longer divide by the number of data points that you've picked up. You must now divide by the sum of the weights. So then you work out your sum product. So 16 times 0.5, that gives you 8. 19 times 0.4, that gives you 7.6. 20 times 0.1 gives you 2. So the average is now 8 plus 7.6 plus 2 equals 17.6. 17.6 divided by 1, where 1 is the sum of the weights, equals 17.6, right? And so we do another average for May. So for May, it would be now 21 plus 21, sorry. So you're going into the immediate past again, 3 data points, but each are now weighted. So it's 21 times 0.5. The most recent is always weighted by the same number given, 0.5, plus the next most recent is 16 times 0.4 plus the third most recent, 19 times 0.1. Good. So you work out that, and that would be now again 21 times 0.5, that's 10.5. 16 times 0.4, that's 6.4. 19 times 0.1, that's 1.9. So you add that up, and so you divide by 1. Again, the sum of the weights. The sum of the weights don't always add to 1. Whatever they add to, that's what you divide by. So your average now is 10.5 plus 6.4 plus 1.9. So and that is 18.8. And since you're dividing by 1, you're going to get 18.8. And then you roll on through to the next one. And so for June, the 3 immediate past data points would be 18 times your 0.5 plus next past would be 21 times 0.4. Next past, 16 times 0.1. And again, you're an expert now, so you know what to do. 18 times 0.5, that gives you 9. And then you have 21 times 0.4, that gives you 8.4. And then you have 16 times 0.1, that gives you 1.6. And of course, you're going to divide by the sum of the weights, again, which is 1. So it's 9 plus 8.4 plus 1.6 equal 19 divided by 1, which is 19. Again, remember, the sum of the weights will not always be 1. So you must check to see what the sum of the weights are. It is only in this case here that we have 1 for sure. There is no guarantee that the sum of the weights will be 1, and oftentimes it may not be 1. So be warned. Do not say, Miss, tell you to divide by 1. I only told you to divide by 1 here because the sum of the weights is 1. All right? So we're going to go through the last of the data in the table, and that's for July. So we're going to have 23 times 0.5 plus 18 times 0.4 plus 21 All right, and so we're gonna add 11.5 plus 7.2 plus 2.1, and that gives us 20.8. Again, we're gonna divide by the sum of our weights, which happens to be 1. It happens to be 1, so that's 11.5 plus 7.2 plus 2.1 equals 20.8. And so that the forecast using the 3-month weighted moving average will look as follows. Remember now, you must read to see how, well, first, what the weights are. You must be given the weights in a weighted moving average instruction. And then, having been given the weights, you must be told how the weights are to be used, how they are to be applied, in what order. And you must figure out what it means. So if it says to the most recent, you must determine where recent will begin. How will you do that? By first finding your starting point by counting off the number of data points that you're asked to use in the average. And then in the immediate past, that will be where your recent begins. right? Good. So we have used simple moving average. We have used weighted moving average. So let's go back and look at them. So we have used the simple moving average, just a 3-month moving average, to calculate the sales for a specific time. In this case, the specific time is in this question, August. So it's just a 1-point calculation. For question 2, no specific time was given. That implicit instruction is you must forecast for the entire table according to the number of data points you must use. So you must begin at the beginning, count off the number of data points you need in the average, find your starting point, and then roll through the entire table using that number of data points until you come to the end of the information that is in the table only. Sometimes you're asked to do a weighted moving average because past data have different influence in the average. The weights tell you the respective influence, like in your grade point average, your GPA. And so you need to be told the weights. And having been told the weights, then you apply the weights according to the instruction given. There is no set rule. You must listen, you must read, and you must seek to understand what the instruction means as to how you must apply the weights. No swatting here. You start reading and understanding what the information means. So you have to apply your English. It's where your English comes to bite you, right? You have to apply your English to read and to understand what that instruction means. So continuing on now with our averaging or time series. Now notice that for the endpoint moving average, we need a lot of data, 3 months, 4 months, 2 months, 5 months, 6 months, for argument's sake, to calculate our forecast. Now, there is a method that's also an averaging method, but it assumes that you do not need so many data points. It assumes that all you need is just the data from the immediate past. And what exactly data would you need from the immediate past? You would need the last forecast, and you would need the last historical actual, in quotation, observation. And it assumes that when you have that immediate past information, that you can use those pieces of immediate past information with another little piece of information that we will talk about in a minute to make a forecast for the future. Now, here is the thought process there with that bit of knowledge. If you know what you have done in the immediate past, you know what you said that the forecast was going to be, you know what actually happened after you made the forecast. When you match the forecast with what actually happened, you were either dead on correct or you are not correct. Well, if you were correct, then your mistakes or your error would be 0 because both numbers would match. But if it is that both numbers do not match, if your forecast was more than what actually happened, or if what actually happened was less than the forecast, then you have what we call a mistake, officially called an error, E-R-R-O-R, or a deviation, meaning that your forecast deviated from what actually happened, right? So what deviated? Your forecast deviated from what actually happened. So you were introducing the concept of an error. Now, what do I do with that error? Well, you learn from it. If you did something in the past And when you match it, or if you made a prediction in the past rather, and then when you look at what actually happened, you realize, ooh, I was too optimistic or I was too pessimistic. Too optimistic means that you made too big a forecast, or too pessimistic means that you made too little a forecast. Then it means that for the next round, you're going to adjust what you are going to do. So that adjustment is carried out through the concept of what we call smoothing. So we introduce two concepts, error, use a different color. Introduce the concept of an error or deviation and a smoothing constant. Now the smoothing constant goes by the name alpha. And it carries the symbol, it's a sideways Greek looking letter. Good. So the next method that we're going to look at says we must have that to make a forecast, we need, so this method says to make a forecast, we need only the immediate past D-I-A-T-E. We need only the immediate past actual observation we need the immediate past forecast, and we need the smoothing constant. Called alpha. Now, when we put them all together, what we have is a forecasting method. I'm trying to find, right. What we have is a forecasting method called exponential smoothing. Good. So it says rather than using a whole heap of data points or many data points to make a forecast, we just use the immediate past actual observation. We need the immediate past forecast, and we need a little bit of information called the smoothing constant, otherwise called alpha. So the exponential forecasting, which is an averaging method under the time series methodology, looks like this in formula notation. It says to make a current observation, we need, or to make a current forecast, sorry, to make a current forecast, we need the immediate past forecast. And we also need to look at what our error was the last time we forecasted. So the error would be the actual observation the last time we have the data minus the forecast that's equivalent to, or not equivalent to, but matches our last actual observation. And when we have that, then we take a fraction of that error. So what is in the bracket is actually an error. So the error is defined as the actual observation minus the corresponding forecast, right? So basically, that's what it is doing. It's taking a percentage, where that percentage is referred to as alpha, of the forecasting error we made the last time we forecast. So immediate past actual. So the actual here is our immediate past actual observation. So it's our immediate past actual observation minus our immediate past forecast. When we have that subtraction, the result is called error. So the statistical definition of error is the actual minus the forecast, right? So if you want to find the error, it's an actual observation minus the forecasted. And then now, this FT minus 1 is your immediate past actual forecast. So to make a current forecast, so current forecast, I'm writing it again, I'm saying it again. You need your immediate past actual observation. So I'm writing it again. Immediate past actual observation plus a fraction of your error, which the error is calculated by taking the immediate past actual observation. And where would you get that? From the table, of course. Minus your immediate past forecast. Now, so you would get your immediate past actual observation from the table. Where would you get your immediate past forecast from? That's a good question. You would either be told what it is, or you may actually have to figure it out for yourself by using what we call the naive method. So to begin with, we will be told what it is. So we're going to work a problem where we're going to apply the exponential smoothing methodology. So I'm going to turn the page and we're going to use our same data, and we are going to work by make a forecast by using the exponential smoothing. So we're going to use the same data. So we're going to have back our January, February, March to July. So you can write up your book again. So January, February, March, April, May, June, July. You put back your number. Remember, they are in unit, they're in thousands, 20,000, 19,000, 16,000, 21,000, 18,000, 23,000, 19,000, right? Now, the instruction here now would be, so I'm gonna tell you the instruction. So this is instruction number 4. We have done up to instruction 3. So instruction 4 would says, forecast sales using the exponential smoothing with a smoothing constant, that is alpha, exponential smoothing with alpha equals 0.2, and assuming January's forecast to be 19. So let's go back to the page. Remember I said that your immediate past actual observation, you find that in the table that you're given. The question is, where would I find the immediate past forecast? You're either told what it is. So notice the question that you were given. You were told that to assume that January's forecast is 19. So you're told something about the first forecast. If you're not told what it is, then that's a different matter. But we're going to begin with me being told what it is. So let's continue. So you're either told or you must deduce it, D-E-D-U-C-E. So you're not just going to use any figure. You have to deduce it. So you're either told or you must deduce it. In the question that we're looking at, we are told what it is because it says assumes January forecast to be 19. So to apply our method, where we say that your current forecast, so we know, so we can write here forecast, right? We're going to calculate them there, F-O-R-E-C-A-S-T. So we know, we were told that we are to assume that January's forecast is 19. So we can write our 19 across from January. Now to calculate the forecast for February, remember what our formula says we need? We need the immediate past actual forecast. Sorry, oh, I said that wrong. We need the immediate. Actual and forecast cannot go into the same term. My mistake there. So what we need is the immediate past forecast. Immediate past forecast. My bad. So let me correct that. So we need the immediate past forecast plus the immediate past actual observation minus the immediate past forecast. All right, see, sometimes the lecturer can say it's a boo-boo too, right? So again, it says the immediate past forecast. See F, see I have F up there for forecast, but I wrote nonsense. So F forecast, so the immediate past forecast. A mean actual observation, F means forecast. So we need the immediate past forecast. And notice we use the immediate past forecast twice. We need the actual, we use the actual observation 1. So to begin, we need an immediate past forecast. Where do I get it from? I'm either told or I must deduce it. In the problem, we are told it. So we simply write it down where we are told that it occurs. It says that we are to assume that January's forecast is 19, and there we wrote it down across from January. Now to make the forecast for February, the formula says we need the immediate past forecast. So if we're at February, the immediate past is January. So we need the immediate, we need the forecast from the immediate past from February, which is January. So we need the immediate past forecast. Plus that little animal that we call alpha, we were told it's 0.2. And we need the immediate past actual observation. Since we're at February, the immediate past is January. Remember I said the actual figures are found in the table. So the actual figure in the immediate past from February would be the figure in the table at January. So the actual immediate observation is 20 minus your forecast, which is 19. So you work the bracket first. Remember your PEMDAS or your BOMDAS brackets of PEMDAS, brackets of multiplication, addition, so on and so forth, right? So you always work your bracket first. So 20 minus 1, sorry, 20 minus 19, I'm getting tired. 20 minus 19 is 1. So it's 20 times 20 minus 19, which is 1 multiplied by 0.2. So I know a lot of you are going to call for your calculators because you don't trust what your mind is going to tell you. So you're going to put in your 0.2 times 1. And you're going to say, oh, Mrs. 0.2. All right. So 20 minus 19 is 1. 1 times 0.2 is 0.2. 0.2 plus 19 equals 19.2. So your second forecast is 19.2, right? You do another forecast. So notice it did not tell you for a particular month, which means you have to roll through the entire table just as that requires you to do. So your next is the immediate past forecast, which is the one you just made, 19.2. Your alpha is given. Now your immediate past actual observation is 19. But your immediate past forecast is 19.2. So, well, it's still the same actual minus forecast. So here it is 19 minus 19.2. So that gives you negative 0.2. So negative 0.2 times 0.2 equals negative 0.04. So what you're going to have is 19.2 plus negative negative 0.04. So let me say that again. It's 19.2 plus negative 0.04, which amounts to 19.2 minus 0.04. And that gives you 19.16. Good. So your next forecast is going to be your immediate past forecast again, which is the one you just made, 19.16 plus 0.2 minus your into your actual observed data point, which is 16 here, minus your forecast, which is 19.16. So again, it is, you work your brackets first, 16 minus 19.16, you get negative 3.16. Good. You multiply your negative 3.16 times 0.2. You get 0.632, but that's negative 0.632. So it's 19.16 minus 0.632, and that equals 18.53. I rounded to 2 decimal places. You will actually get 18.528, but I'm rounding to 2 decimal places. And 2 decimal places are always safe to do, right? If you're not given any instructions as to how many decimal places. So that's 18.53. Remember, it says it's actually 18.528, but I'm rounding to 2, right? And we're going to keep that 2 steadily. So then we roll through again, we continue. So it is our immediate past forecast, which is 18.53 plus our 0.2. You get your immediate actual past, actual observation, which is 21, minus your immediate past forecast, which is 18.53, rounded to 2 decimal places. So notice now it is 21 minus 18.53. That gives you 2.47. So the bracket gives you 2.47. You multiply that 2.47 by 0.2, That gives you 0.494. Good. So it is positive 0.494 plus your 18.53. That gives you 19.02. Again, I'm using 2 decimal places. So it's 19.02. If you're going to round, remember to apply the rules of rounding. So it's 19.02. You make your next forecast, which is your immediate past forecast, and you just make it 19.02 plus your smoothing constant of 0.2, your immediate past actual observation, which is 18, minus your immediate past forecast, which is 19.02. So notice if you over forecasted, you corrected yourself later, and if you under forecast, you correct yourself, right? So again, it is 18 minus 19.02. And so that gives you negative 1.02. Remember, you're always working your brackets first, negative 1.02. You multiply that negative 1.02 by 0.2. That gives you negative 2.04, right? So it is 19.02 minus I forgot what I was saying. So it's negative 1.02 multiplied by 0.2. That gives you 0.204. And that's negative 0.204. 19.02 minus 0.204. And that equals 18.82. So I'm using 2 decimal places and I'm rounding according to the rules of rounding. And lastly, we get to the last one, which is July. So it's the last forecast, 18.82 plus 0.2. Your immediate past observation, which is 23, minus your immediate past forecast, which is 18.82. Again, you work your PEMDAS or your BUMDAS brackets of multiplication, division, addition, subtraction, right? So it's 23 minus 18.82, that gives you 4.18. You multiply 4.18 by 0.2, you get 0.836. So you add 0.836 to 18.82, and your last forecast is 19.66. Again, it would be 19.656, but I'm rounding to 2 decimal places. So you have made your forecasted sales using the exponential smoothing with alpha equals 0.2. I know I might have said the wrong word, but I wrote the right thing. So please pay attention to the corrections that I've made so you're not confused, right? So this is also a time series methodology. It is an averaging method, except that rather than using multiple data points, you only use one actual observation from the past and the corresponding forecast from the immediate past. And you apply a fraction to your arrow from the last action you took, and you roll that into the future. So notice that you were not asked for a specific forecast. You were simply asked to forecast sales using exponential smoothing. If you were asked to forecast sales for a particular time, then it means that you must zero in on that particular time and use the data from immediately before. For example, if you're asked for sales from June, you would have to determine what is the immediate past information that I would need. So to forecast sales for argument's sake for June, You would need the actual observation from the month before, which would be the actual observation from May. And you would need the corresponding forecast for May. And so you would have the immediate past information, both in terms of actual observation and in forecast that you need. So again, note the distinction in the instruction. You might just be said, you just might be told to forecast sales for when you're not told. It means you must go through the entire data set. But if you're given for a particular data point, you zero in on that time frame and look for the relevant data to do that forecast. All right, so we have looked at, under the time series, we have looked at using a simple moving average, where our n here, our simple number was 3. Could have been 4 or 5 or 6, but 3 is just a nice number to use. So we use an n simple moving average. We learn to apply to a specific time period, and we learn to apply it how when it's given us generally. Then we moved on to a weighted moving average. And we saw that for a weighted moving average, we need to be told what the weights are. We need to be told how to apply the weights, as well as we need to be told how many data points we must pick up. The number of weights that you're given must match the number of data points that you're going to be used. So for argument's sake, you can't be told to do a 4-month weighted moving average and you're only given 3 weights. Each data point must have its weight. So if you're going to be given a 4-month moving average to do, you must be given 4 weights and you must be told how to apply those weights. Then we looked at the exponential smoothing methodology, where in the exponential smoothing methodology, we need to have an immediate past actual observation. We need a corresponding immediate past forecast, and we need a smoothing constant called alpha. So with those 3 pieces of data points, we can make a forecast. Now, I said that when you're going to use the exponential smoothing, let's go back to this page. I said to you that you're either told what the immediate past forecast is, or you must deduce it. Good? Now, in the question that we just worked, we were told what the forecast was. Suppose I set the question like this. So I'm going to go and I'm going to replicate the information. I'm going to give you the instruction, but without telling you what the immediate forecast is, immediate past forecast is. So we're going to go to the next page and we're going to write back the same data. So we're going to have our January, February, March, etc. So we're going to have our January, February, March, April, May, June, July. Now, we're going to write back our figures: 20,000, 19,000, 16,000, 21,000, 18,000, 23,000, and 19,000. Suppose your instruction now is use exponential smoothing. So the instruction, so use exponential smoothing with alpha equals 0.2 to forecast sales. Notice in this one, you know you need an immediate past actual observation. Fine, you can get it from the table. information in the table are actual observations. You know you need a past forecast, but notice that, Miss, you never gave me the forecast. I can do this. That's what you would want to say. I know alpha, but piece of the information is missing. Not so fast, right? If you were not given it, then you must deduce it. So how would you deduce it? You would need to use the naive method. Remember at the outset, I said the naive method is where you simply assume that what is going to happen currently is what happened in the immediate past. So you use that thought process to generate your first forecast, to deduce your first forecast. So you don't pluck it any number out of the air. You actually apply a method. So here, you don't know what time zero was. That means you don't know any information about what happened before January. You know what happened January. That's where your observations begin. So since your time information begins at January, you can say, okay, since I know what happened in January, I can't make any deduction in terms of forecast for January because I knew not what happened before January. So I said I can't make any forecast there. But going forward, I can take January's observation and use it as what I deem will happen for February, or I can use it to make a forecast for February. So what you will do, so that is the application of the naive method. So you will now use January's actual observation to be your first forecast, and that forecast will land in February. So that is how you will deduce your first forecast. So notice it says use exponential smoothing with alpha equals 0.2 to forecast sales. Meaning when you get that wide instruction, it means you must start from the beginning. So then you are going to continue now by now you apply the formula. You need your immediate past forecast, which you just deduce using the naive method. So your past forecast would be 20 plus your past immediate actual observation would be 19. Your past immediate forecast would be 20, and your alpha will be 0.2. And you work that out and you roll through to the end of the data like you normally would. So you're just deducing your first forecast here if you're not told what it is. Good? Now, suppose it was that you were asked to make a forecast for, say, May. But your first forecast was given at March. Then it means that you would have to write your forecast of March and then apply your method at April and work down to May. So again, you must look to see where the forecast is given for when the forecast is given. And then you put it in the slot that it is given, and then you work to where you need to go. All right, so again, you need to think. It is not just, oh, let me swat this, and this is what it says. You must look, read, listen to the principles I've delineated, and you must seek to understand what it is that Miss has said. How do these principles work? How do I use them in new situations to help myself to answer the questions? Remember, I said that my goal for you is to become independent thinkers by teaching you the principles. So I'm giving you variations on situations that you may need to apply the principle in. But once you know the principle and you're able to manipulate the principle to meet the situation, you are good to go. And that requires practice. So that is just a plug for you to begin working on your tutorial sheets and not wait until the day before the exam. Outcome won't be pretty if you do that. And I want pretty outcomes. All right, good. So that takes care of our exponential smoothing. Again, to reiterate, back ways, we've used exponential smoothing, we have used weighted average, we have used simple moving average, and we have even applied the naive methods here. So we have used 4 different, well, basically 3, but applied 4. So we have applied 3 different time series averaging methods to come up with forecasts. You realize that? And we're always using the same data. So we're going to collect them in one table, all right? So we're going to go back and we're going to look at our forecasts, right? So let me go back to the tables. So we're going to take a look. So when we use the 3-month moving average, right? So I am going to make up another page and we're going to look at what happened, what we just did. We're using, notice we've been using the same set of data, the same 2019, 16, 21, etc. And we've been applying different time series methodologies to the same actual observations. So I'm going to make up a table. I'm going to collect them. So here we have our actual data, right? So we're just putting everything that we have done together. We have our ACTUA. I'm sorry, class. I tend to scribble, you know. We have our actual data, right? January, February, March, April, May, June, July. And the actual data we had was 20, and we know that it is in thousands. 19, 16, 21, 18, 23, and 19. And then we set out on a journey. We did a 3-month moving average. We did a 3-month moving average forecast, and let's gather those forecasts here. They were 18.33. Where's my pen? All right, 18.33. I wrote it at the wrong place, didn't I? It's 18.33. All right, so that would be April, 18.33. We have to write them at the correct point. So then 18.67. And then 18.33 and 20.66. So when we use the 3-month simple moving average, then that was what we had for April. It was 18.33, May, 18.66, June, 18.33. And then we went on. We said, okay, we explained why we're going to use the weighted moving average. We said sometimes the weights, the data points carry different influence on the average. So the weights will tell us those influences. And then we use a 3-month weighted moving average. All right. So notice the number of data points can differ between the 3 months simple and the weighted moving average. I could say a 4-month weighted moving average. It doesn't make any difference in terms of number of data points. The important thing is here is that you're using a simple moving average as opposed to a weighted moving average. All right. So for April, it was 17.76. And this is your 3-month weighted moving average, 17.76 and 18.88. 19, and the last one was 20.88, right? Good. So our 3-month moving average, 3-month weighted moving average, and then we have our exponential smoothing. Under exponential smoothing, started from scratch. We had 19 for January, 19, 19.2. Yes, and we pick up the one that we were told, so don't leave it out. 19, 19.2, 19.16. And then we had 18.53 and 19.02. Then we have 18.82, 19.66. I hope I picked them up right. Sure. 19. Let me make sure of that. 18.82 and 19.66. Did I have it right, class? 18 point, right. So nicely written out. So we use 3 different methods of time series. We use the 3-month simple moving average, a 3-month weighted moving average, and we use the exponential smoothing. And if you look at the data side by side, we're using the same actual information, that is the information that's written in black. And we have generated 3 sets of data from that same information. One set is written in red, one set is written in green, and one set is written in blue. So remember at the outset, I said that managers want forecasts to help them make decisions. So the question is, when the managers see these 3 sets of data coming from the same actual observations, what is the manager to do? How will the manager decide which set of data he or she should use to make forecasts, to plan? Because that's why you need forecasts, as I said, to plan for the future. So that's a question that the manager or the forecaster will have to answer. Sorry. So the question now that the forecaster will need to answer, which is the best forecast to use for planning? Which is the best forecast to use for planning? Well, the answer is the most accurate. So the answer is the most accurate forecast. And so the follow-up question is then, Miss, how do I determine the most accurate forecast? If we have 3 of them, what do I do to determine the most accurate forecast? Good question. Now, the most accurate forecast is the one that has the least error. Aha, so when I talked about the error early on, I was just setting you up, not true, right? So the most accurate forecast is the forecast that contains the least error. So Miss, you're saying I have to go find the error in all of the forecasts them to see which one have the least forecast? Exactly so, you're right. You must find the error that is in each of the set of forecasts that you made before you can determine which is the most. Most is a superlative, meaning you're comparing something at least, good, better, best, little more, most. So you know that you're making a comparison, right? So the question then is, well, what do I do? I said earlier that the error is calculated. I said earlier that the error is calculated by taking the actual observation and subtracting the corresponding forecast. So that's going to come in handy. Now, so if I take the actual observation and minus the corresponding forecast, I get the error. So then if we do that for each forecast that we have, we will get a number of error for each of the forecasts that we have done, each of the forecasting method that we use. So then we're going to use the system of error to determine which of the forecast method that we have used to generate our different forecasts, which is the most correct. So our response here calls for what we call the error analysis. So we're going to do our error analysis. We're going to do the error analysis to determine which of our forecast is the most accurate forecast. So I'm going to turn the page and I'm going to head it up, error analysis. Now our errors can be tabulated according to the percentage of error that we find in the forecast. The percentage of error is called our mean percentage. So our mean absolute, ABSO, percent error, or MAPE, MAPE for short, mean absolute percent error. Now, mean means average. Absolute means that you have converted all negative results when you calculate the error to positive figures. Not just simply writing the negatives as positive. At this stage, that's what you do. We're not going to go into the mathematics of it, right? So where you see absolute, it simply means that if you tap in the actual information and you subtract the corresponding forecast and you get a negative figure, you write it down as positive. So that's what it really works out to be. And we will just use that for simplicity. And you convert that to a percentage, right? So the wording simply tells you that you take the absolute errors, you convert each to a percent and you average it, and that gives you the mean absolute error. So that's one way to do an error analysis, is to use the MAPE methodology. The next way to do your error analysis is to use the the squared error, the mean squared error, or the average squared error. So remember, another word for average is the mean, right? So the mean squared error, which simply means you find the error, you square it, sum them up and average it, right? So you have the MSE. And the one that we normally ask you to use is the average absolute error. Another word for error I'd mentioned earlier is deviation. So the average absolute error, ABSOLUT, that's what I wrote there. Remember, another word for average is mean, right? So it's the mean absolute error. And another word for error is deviation. So it's the MAD, mean absolute deviation, where deviation is just another word for error. So there are 3 ways to conduct your error analysis, or 3 ways to, what's the word I'm looking for, to summarize the errors that you have determined that is in your forecast. You can actually use the MAPE, that is, use the errors to look at the percentage of the error that it constitutes, or you can square the errors to look at the average of the square errors that is present, or you can use the absolute error, the average of the absolute error, to determine the level of error that is in your forecast. We're going to look at just the MAD at this point. So let's go back to our page. Now remember, I said that for your error analysis purpose, the error is calculated as actual minus forecast, meaning your actual observation minus the corresponding forecast. So where there is no forecast to match the actual observation, you cannot calculate an error. Where there is no corresponding forecast, you cannot calculate an error. So for example, if you look at the 3 months moving average, you cannot calculate an error for January, for February, for March, because there's no corresponding forecast to the actual observation of 2019 and 16. Likewise, for the 3 month weighted moving average, you cannot calculate an error for January, February, or March because there's no corresponding forecast. But for the exponential, you can calculate an error beginning from January because there is a corresponding forecast. So note that. I know it doesn't make a difference to the problem. You begin where the data has a corresponding forecast. Begin calculating your error where the data has a corresponding forecast, okay? All right, so then an error though may either be positive or negative, meaning you have over forecasted. If it's positive, it means you have under forecasted, sorry. And if it's negative, it means you have over forecasted, right? So the error itself may be positive or negative. So when you minus the forecast from the actual, you may get a positive or a negative figure. But when it says absolute, it means that if that figure that you get is negative, you must write it down as positive. So let us apply that here. So I'm going to use the black marker to work in between. My energy is waning. So we're going to calculate the error for the 3-month moving average using the MAD, right? We're only using the MAD. So we're doing the MAD, so I'm going to write sideways, for the 3-month moving average, right? So what I've just scribbled in black is the MAD for the 3-month moving average. So we can't calculate an error for January, for February, or for March, but we can calculate an error for April because there is an actual and a corresponding forecast. So it's 21 minus 18.33, and that is 2.67. Good. And then for May, it is 18 minus 18.67. Sorry. Yeah. Yeah, for May, it is 18 minus 18.67. That actually gives you negative 0.67. But remember, the absolute says you must simply write it down as 0.67. So you ignore the negative sign, right? For June, it's 23 minus 18.33. That's 4.67. That's actually positive. For June, it's 19 minus 20.66. That is negative 0.16, but since we're using the absolute, it's 1.66. We take off the negative. And so you sum those absolute figures. So 2.67 plus 0.67 plus 4.67 plus 1.66 equals 9.67. How many data points did we just add up? 4. You divided by 4. So 9.67 divided by 4 equals 2.42. I'm using 2 decimal places, 2.42. Good. And we do a similar move for the 3-month weighted. For the 3-month weighted, it's 21 minus 17.66. So it's 21 minus 17.76. That's 3.24. Then it's 18 minus 18.88. And that's negative 0.88, but we ignore the negative because we're taking the absolute value and we just write 0.88. And then for June, it's 23 minus 19. That is a solid 4. And then for the last one, July, it's 19 minus 20.88. That's negative 1.88, but we're using the absolute figure, so we write 1.88. Again, we sum them, 3.24 plus 0.88 plus 4 plus 1.88, we get 10. We just added up 4 numbers, so it's 10 divided by 4. That's 2.5. So we have 2.42 for the 3 months weighted. We have 2.5 for the 3-month weighted, and we're going to do the exponential now. For the exponential, it's 20 minus 19, and that gives you 1. Oopsie. So it's 20 minus 19, and that gives you 1. It's 19 minus 19.2. That gives you negative 0.02, but we're simply going to write down the 0.2, right? Then it's 16 minus 19.16 is negative 3.16, so we're going to write down 3.16. And then now we're at 21 minus 18.53. That's 2.47. And then it's 18 minus 19.02. And that's negative 1.2. We write down 1.02. And then it's 23 minus 18.82. That's 4.18. And then that's 19 minus 19.66. That's negative 0.66, but again, we're writing down the positive, so we write 0.66. And where I scribbled that talking it, calling it out, gives you a pointer, right? So then we're gonna add up those numbers. So it's 1 plus 0.2 plus 3.16 plus 2.47 plus 1.02 plus 4.18 plus 0.66. That gives us 12.69. And we are going to divide by 1, 2, 3, 4, 5, 6, 7. So it's 12.69 divided by 7. And that's 1.18. 1.81. So our MAD for the 3-month moving average is 2.42. The MAD for the 3-month weighted average is 2.25. The MAD for the exponential is 1.81. See, I'm circling them in red so you follow. The board is cluttered, but I've spoken through everything that's on the board. So if you listen, you should be able to follow how the information got on the board. So remember, we said, which is the best forecast to use for planning? We said the most accurate forecast, of course. How do we find the most accurate forecast? We must do an error analysis. How do we do the error analysis? Well, we must know what an error is first. And we know what the error is here. The error is found by taking the actual and subtracting the forecast. We said when you do that, you'll get a positive or negative number. Now, how you use that number depends on which method of error analysis you're using. We said you can use the mean absolute percent error. We can use the mean squared error, or we can use the mean absolute deviation, where mean is just meaning average, and deviation is not just another word for average. So here we have used the mean absolute deviation, meaning we find the error first. If it is negative, we simply call it a positive. We do that for each pair of actual and forecast that we have. We add them up as the block columns show for each of the different forecasts, and we average them. And we look at them. For the 3-month moving average, it is 2.42. For the 3-month weighted is 2.5. And for the exponential, it's 1.81. So if these numbers that are in circle represents error, then it means the smallest error is the one that is the most accurate forecast. So therefore, the most accurate forecast would be the exponential smoothing. So the most accurate forecast is the exponential, exponential, exponential smoothing, because it has the least error of 1.81. And therefore, when you recommend to your manager what the forecast should be, or what the preferred forecast is, then you're going to recommend the forecast to be the preferred one as the one that has the least error, as is measured by one of the error analysis methodology, in this case, the MAD. And the MAD gives you the least error in the exponential smoothing of 1.81 as compared to 2.42 in the 3 months or 2.5 in the 3-month weighted. So note it is the method that you are recommending, not the error, but you're using the error to determine what to recommend. Good? So you would therefore recommend to the manager that he uses the exponential smoothing as the preferred method to make future forecasts. So if the manager says to you, well, forecasts for the next month, what the likely sales will be, you will now use the preferred method that you just recommended, which is the exponential smoothing. So you will use the exponential smoothing to make a forecast for the next month, where the next month would be August. So I'm going to turn the page. That's not what I want. Good. So forecast for the next month. Where the next month would be August. I'm going to continue writing. Oh, instead I've created the maximum number of pages, I'm going to have to use this page, right? So it's a forecast for the next month, which would be August, would be done by using the exponential smoothing. So you would go back and you would look at the information that you need. The last actual observation would be 19. So you would use your 19 and your 19.66. Use your alpha 0.2 and you plus your 19.66. So that would be equivalent to, in your brackets, 19 minus 19.66. So you take out your calculators and you tap in. I know you guys like to use a calculator for everything. So 19 minus 19.66, that will give you negative 0.66. You have your 0.2 and you have your 19.66, and you multiply by your 0.2, you get negative 1.32, right? So you'll have 19.66 minus 0.132. That will give you 19.53. to 2 decimal places. So your forecast for August using the preferred method would be 19.53 using the preferred method of the exponential smoothing, because the exponential smoothing is the one that has the least error. So that takes us to almost the end of looking at the methods under the time series. So we have looked at exponential smoothing. We have looked at weighted moving average or simple weighted moving average. We have looked at the simple moving average. We have applied the naive method. We have looked at how do we determine, since we are applying so many methods, how do we determine which is the preferred forecast? We did that by using an error analysis. And we saw that you could do error analysis in 3 ways. We could use the mean absolute percent error, we could use the mean squared error, and we could use the mean absolute deviation. We'd use the mean absolute deviation here. And we realized, we saw that we must calculate the error for every single forecasting method that we used. And when we calculated the error for every single forecast that we generated using the different methods, we picked the method as the preferred method, the one that carries the smallest error. And we recommend that to the manager as the methodology to use to carry out any future forecast. And we carried out a future forecast based on the recommendation of the preferred method of the exponential smoothing because it has the least error of 1.81. Our look at forecast was time series and series by looking at trend, and then we look at the causal methods of regression analysis. So revise to your tutorial sheets. Having done the lesson through this semester, see you next class.